Hello to one and all. I am Carl Stindiao, a student in PhD Mathematics Education. In this video, I'll be presenting to you the score assignment model in finding the maximum group score under operations research. So, without further ado, let us begin. For the learning objectives, the objective of this video presentation is to assign potential scores to individual students per subject area, to identify and formulate the objective function, decision variables, and constraints from the given dataset, to utilize Microsoft Excel's data analysis tool, namely Solver, in determining the highest possible group score as the optimal value or the maximum, and to provide a sound conclusion on the score assignment model. Now, let us have some situational problems to investigate. In a certain college, Section A is partitioned into several groups throughout the semester, one of which is the academic committee, whose members are Bethany, Kenneth, Isabel, William, and Jennifer. The group must answer major assignments in English 102, Science 105, Education 103, and Computer 107 with their corresponding points. Now, with wise decision, they agreed to assign potential scores to themselves on each subject and determine the maximum group score for the tasking. Now, using Microsoft Excel, we can see the potential scores on each subject area that the students assign themselves. Please take note that one student is only assigned for one assignment, and one assignment is only for one student. Also, there are two types of assignment model. The first is balance, and the second is unbalanced. For the balanced assignment model, the number of columns must be equal to the number of rows. Otherwise, it's called unbalanced. Let us see in this case. Now, for the number of columns, it's 5. And for the number of rows, it's 4. Since 5 is not equal to 4, then we can say this assignment model is unbalanced. For assignment model that is balanced, it is convenient. To make it balanced, let's add another row called the dummy component. And we have its values as 0. Okay, so this will be our data set. Now, our goal is to find the maximum group score. To do that, we have to include the objective function, decision variables, and constraints. The first step for that will be creating the decision variable table. So we have this table. Let us erase this. Let us suppose that the numbers in each of the cells here on this table are binary, meaning 0 and 1. Okay? Now let's go or proceed to the next step. Let us find the sum for each row. Okay? Drag this down. Find the sum for each column. Drag this to the right. Okay? Now let's proceed to the objective function. It's very clear that the objective function is our group score. Okay? And how do we get that? To get the group score, since it's binary and one student is only for one assignment and vice versa, we can use the sum product function. Okay? So this area, comma, this area. Okay? Enter. As you can see, it's 0 because in the values of the decision variables, it's empty or 0. If we place 2 here, then we can deduce that we have 132. Okay, since 66 times 2 is 132, and the other addends are 0. Okay, let's erase this. Okay, now this time, we'll find the maximum score. To do that, we go to data, and we will now apply the most useful tool in optimization, solver. Okay, so let us have this. So the objective function is this one. We will find the maximum. Now, for the decision variables, this area, what are the constraints? That's the question. Now, we all know that the numbers of the decision variables are binary. So this area must be binary. And the sum for this in each row must be equal to 1 because it's a 1-to-1 correspondence for the subject area and the students. And this one must also be equal to 1. Now, all of the constraints are good. The decision variables and also our objective function. So let us solve it. Solver found a solution. As you can see, it's 279. And that's the maximum group score that they can attain. Okay? So we have max group score. And as you can see, William will answer English 102. Bethany will answer Science 105. Isabel will answer Education 103. Kenneth for Computer 107. And Jennifer, in which she will not answer anything. To understand deeply, let's have another example. A provincial mathematics competition will be held soon. Professor Z is the coach for this year's contest of the following students: Noah, Luna, Owen, Bea, Ryan, and Zoe. However, he is yet uncertain on who will compete for algebra, geometry, trigonometry, statistics, combinatorics, and calculus. But after a brief time of thinking, he realized that maximization is the key. He instructed them to write their possible scores that they can obtain out of 100 points in each branch to identify the optimal solution. Okay, this is example number 2. So the potential scores are there already. So let us do the same process as score assignment model number 1. So we will be duplicating this for the decision variables. Okay, erasing this and finding the sum. Okay. All right. Still the same. The objective function is the group score, and we'll be finding the maximum score. To do that, we'll be using sum product. Okay, comma, the other table. All right, it's 0. As you can see, the given data set before or previously is already a balanced data set. No? So that's why no need to put a dummy row, because the number of columns is equal to the number of rows, which is 6 equals to 6. Now, next will be solver. As you can see, it's actually quick when we use solver. Okay, so we have set objective, this objective function, finding the maximum score, and our decision variables will be this area. Okay, and what are the constraints? This one, this area must be binary. Okay, and for the sum, this one must be equal to 1 since it's a 1-to-1 correspondence. One student will only answer one assignment and vice versa. And this also. We are now done. Okay. Now let us solve it. As you can see, solver found a solution. Okay. So the maximum points will be 545, no? That's the maximum score or points that they can earn in the competition. So, Owen will compete for algebra, Ryan will compete for geometry, Luna will compete for trigonometry, Bea for statistics, Zoe for combinatorics, and Noah for calculus. That's all for the video presentation. I hope you have gained some useful insights and understand the concept of the score assignment model. Thank you.